For our next video, we're going to take a look at some more factoring, but this time we're going to look for when a is not equal to 1. The good news is in the first video, we've already learned the process, so at any time in this video, if you feel comfortable with just going ahead and factoring, feel free to do that. In the first example, I'll go through more step by step, but I'll probably go quicker through the last few. First example, I didn't list the steps, but like it says, same steps apply. So our first thing is to multiply a and c. In this problem, the a actually has a value that's not 1. So we want to multiply 2 times 5 and come up with 10. So this is where things are a little bit different. Before, we would just pretty much look at the values of c, but now we're looking at a times c. So you want to think to yourself, what are some facts that work? Well, we already have 2 times 5, but those two together give me 7, not 10. I know everything's positive, so it's got to be positive. That only leaves one option, which is 10 and 1. So 10 times 1 gives me 10, which is AC, but they also add together to give me 11, which is B. So just like before, we're going to take out the original B, we're going to take out 11x and put in 10x and 1x. From this point on, the steps are very, very similar. It's really just the first problem that had some issues with that. When we factor, there is something a little bit different. If you notice, I didn't just take out an x from the first half. I also had a number that went into both of those values. So I took out 2 and the x and was left with x plus 5. I went ahead and filled in x plus 5 first, but then I had to figure out what to take out of it. Since there really wasn't anything I could take out of it, I mean it already was x plus 5, you just would pull out a 1. I hadn't shown you an example like that, so I did want to make sure you saw it. Just like before, we're going to put together our 2x plus 1 and our x plus 5 to get our two binomials. And as I said before, I would suggest you use FOIL to make sure that you are correct. So like you can see, it's really not that terribly different than the problems that we did before. We just have a few more things to look out for. We're going to move right next into a quadratic equation where we're going to actually solve it. And if you notice, we have two key steps. The first step is we actually want to go through and factor. What I'd like you to do is to try to see if you can factor this on your own. I'm going to go ahead and give you about 10 seconds, and I think it'd be nice if you paused it and gave it a try. So our first step is the same. We want to do 3 times negative 4, and we get negative 12. And we want to add up to our b, which is negative 4. So since we have a negative AC, that means one of the values is positive and one of the values is negative. So you might think to yourself, okay, well I did 3 and negative 4, that would give me either a negative 1, or if it was negative 3 and 4, it would give me a positive 1, so that didn't work. So after I played with numbers for a little bit, I came up with negative 6 and positive 2. They multiply to give me negative 12, but they add to give me negative 4. We continue our steps like usual. We place them in the middle. We have our negative 6x and our positive 2x. Now there's a chance if you guys moved ahead and solved, you may have these in two different locations. It's really not a big deal. If there's a negative and a positive, I usually go with putting the negative first because I don't need to factor out a negative in the second half. We separate them. We factor out from each piece. We factor out a 3x here. We can factor out a 2 here, and then we can put them together. So our first step is just factoring. Now we need to apply the zero principle, which is, if both of these are multiplied and equal 0, one of them has to be 0. So we set them both equal to 0. Now, students tend to get confused with how we solve these equations. The second equation is not a problem because it's just like the ones we solved where the value of a was 1. But this one here is a little bit different. So let me just show you the steps really quick. So to solve this equation, we want to subtract 2 from both sides. And then to isolate the x further, we need to divide by 3. So the two values that work are negative 2/3 and x, which is 2 here. Now, we can do FOIL to check here, but to solve this problem, if it's an equation, we do what we always do. We plug it back in and we see if it works. And if you were to plug in negative 2/3 to this equation, it would work, and so would using the value of positive 2. So it's always good to give it a try just in case and see if that works. Move that over just a little bit in case you can't see that. Now, to mix it up a little bit, there's really nothing new to these problems. There's really nothing that's too much different. So what I decided to do is to give you two more to try, and just like the last video, I'm going to let you try it with the video and have the answers on the video. So I'm going to watch the timer on my camera. I'm going to give you about 10 seconds, so you may want to pause it, to solve both problems, and then I'm going to show you the answers. And here's the answer to the first one. AC is 28, B is negative 16, so these two values worked. You can go through and see my work down here. Notice I left them in fraction form. You could have 0.5 or 3.5, it's no big deal. I just tend to stick with fraction form. For the challenge, I gave you the hint that B is 0. So you're looking for things that multiply to give you negative 36. This is one of those difference of perfect squares that you've probably heard of before. So I'll give you just a second to look at that. And that concludes our review of factoring.